Okay, this video is about lines of best fit and the correlation coefficient. I'm recording it with my baby in the background, so you might hear some noises. There she is. Okay, so lines of best fit and correlation coefficients are for two variables. So when you record two pieces of information, that's what the first note is going to say here. When discussing correlation, we're talking about two sets of data. So for example, comparing the height and weight of a bunch of people, or comparing the weight and the GPA of a bunch of students, and trying to determine if there is any kind of relationship between your two variables. So that's what correlation is all about. This is what you'll be doing for your project, taking your two variables and comparing them, determining what kind of correlation might exist between them, and then hypothesizing about the reason why you think those two things might be related. I mean, height and weight is a pretty logical one. You know, the taller somebody is, the heavier they're likely to be. Of course, it's not perfect, but it's a trend. So the types of trends that you might see would be a positive correlation. This would be where, as the independent variable increases, so does the dependent variable. So the independent variable is your x-axis variable, and the dependent is your y-axis. And if you were comparing something like height and weight, the height would be your independent one. Right? Your height is not going to depend on your weight, but it's possible that your weight might depend on your height. So we're going to put our independent variable always on the x-axis, and then each person in your study, if you have 100 people in your study, each person is going to be a point on your graph. So let's say you have somebody who's relatively tall and also, you know, relatively heavy. So they're going to be somebody located like there on the graph. Versus you have somebody who is short and does not weigh a lot, that person would be here. If you had somebody that was medium height but very heavy, right, they would be here. So that's how a scatter plot is going to work. And a positive correlation is that, in general, when you plot all your points, they make an upward trend. So as your x variable increases, so does your y variable. Negative correlation would be that as your independent variable increases, your dependent variable decreases. So the y values are low when the x values are high, right? If you look at this point right here, it's going to have a high x value because it's all the way over here, but it's going to have a low y value because it's only this far up. No correlation would be if you plotted people on your graph and the points were randomly scattered. So you had tall people that didn't weigh a lot, tall people that did weigh a lot, moderate height, you know, moderate weight, low height, high weight, all different kinds. So your points are scattered all over the place. Abigail was excited about that. Hi, Abigail. Okay. Correlations might be strong, moderate, or weak. I hope you can tell the difference in these three pictures. They're all positive because they're all going up. But this one is a nice tight correlation. This one is a moderate correlation. It's getting slightly more spread out, but still positive. And this one is a pretty weak correlation. So that's probably what you'll see in your study when you make your scatter plots. It might have a general trend. The points are going to be pretty spread out, not that tightly clustered around a central line. Correlations may be linear or nonlinear. For our project, we're mostly going to see linear relationships or no relationship at all. It's very unlikely that for your project you're going to find some other kind of correlation like this one, which almost is like a circle. It's hard to find data that fits those weird shapes. Generally, our data is going to take the shape of a line. To draw a line of best fit, so this would be like if you had your points in a general positive correlation and you wanted to draw a line that went through the center of this data, it's going to be approximately here. It does not have to cross the axis at 0, 0. I should probably shift that down a little bit, actually. And the way you kind of judge where that line should be is that you want an even number of points above it as below it. That's how you determine the kind of slope and location of the line. So you want an even number of your points on the scatter plot to be above the line of best fit and below the line of best fit. And it's really just an estimation. It's not a precise line when you do a best fit line. The one calculation that I do want you to make for a best fit line is to find the mean of both of your data sets. So find the mean of your first variable and the mean of your second. So if you're looking at height versus weight, you want to calculate what is the mean height of all the people in your survey and the mean weight of all the people in your survey. And that point would look like this: x with a bar over it, comma, y with a bar over it, right? I should put those bars here. You're going to plot that point on your graph. So all the red points on my graph here are all the people in my survey. I'm going to put a green point that would represent where my mean is. And when you draw your line of best fit, you want to make sure it goes through that mean point and, of course, has the same number of points above as below the line, approximately. So that's the one way to kind of determine that your line goes through the center of your data, is that it's going to go through the center of the y and the center of the x, also known as like the mean of x, mean of y. Okay? And then the last bit here is the correlation coefficient. So how can we put a numerical value on how strong the relationship is? Is it a tight, strong relationship, or is it kind of a spread out, weak relationship? And is it positive or is it negative? So there is a number that we use to represent the tightness of that relationship, and it's called the correlation coefficient. You'll almost never hear me call it by its full name, which is the Pearson's product moment correlation coefficient. Generally, I'm just going to call it R, because that's the letter that we use to represent it, and that's what it's going to say on your calculator screen when we calculate this. But R is called the correlation coefficient. R can only take values between -1 and +1. So let me just scroll back for a second to look at this slide of strong, moderate, and weak. This line over here, this relationship is very strong. It's almost a perfect straight line. This would probably have a correlation of like 0.9, because it's very close to being 1, which would be a perfect straight line. This one probably has a correlation of around 0.75 or 0.7. It's pretty tight, but it's not quite as strong as the first one. And then this weak correlation might be something like 0.5. Once it gets lower than 0.5, it's hard to even really tell that it's forming a linear relationship. So let's look at the breakdown of those R values over here. When R is between, let's see if I can blow this up. When R is between 0 and 0.25, the correlation is very weak. I mean, it's almost not, you can't even see it from the graph. It almost looks like it's just a perfect randomly spread out pattern. Between 0.25 and 0.5, sorry, the correlation is weak. Between 0.5 and 0.75, it's moderate. And once you're above 0.75 up to 1, that's considered to be a strong correlation. That would be a pretty tight line. And it's most likely that your R values for your project are going to be between, my guess is 0 and 0.5. So very weak or weak. But if you have good related data, you might get a more moderate or strong correlation. To calculate correlation, you're going to use your calculator. You're going to find that correlation coefficient on your calculator. And I'll show an example on my Inspire. That's why I've had it up this whole time. So here's a list of data for a football league. It's showing the position of the team and the number of goals that they scored in the season. I'm guessing that's what that means. So we're going to go to a new document. So if I go to my home screen and I add a new document, not going to save my old one. I'm going to add a list and spreadsheet page for my data. And there is a way to do this on Excel as well, which we'll do in class for your project. But for a textbook example, like for your homework, you can just use your calculator. It's a smaller anyway, number of points. So we can type in a name for our first variable, which here is position, so I'll type it as POS. And type in a name for your other variable, which here is goals. I'll spell it out. Remember to name your data when you're using the Inspire. We want to do 1 through 20 as our positions, and yes, unfortunately, on the calculator, you need to type them all in individually. On Excel, there's a way to populate these fields automatically, so you don't have to type them in each time. We don't have that here. Boy, I wish I had picked a smaller data set for this example. All right, I'm going to go up and enter my Y value. So I have 75, 68, 60, 49. Just bear with me if I make a mistake. 59, 50, 55, 46, 57, 49, 48, 39, 44, 56, 54, 37, 42, 37, 40, 27. Oh, I got through that pretty well. Okay. So I've got all my X and Y data typed in, my two variables, and now I'm going to go to Menu, Statistics, Stat Calculations, and on this list there's a few places where we can find R. For the sake of our class, I'd like us to find it under Linear Regression, because we're going to be using linear regression in the next section of this chapter too, and it's nice to have it all on one slide. Today we're going to ignore the rest of the information and just find R. So go to number 3 on this list, linear regression, mx plus b. Select your data. So our first variable is position. Our second variable is goals. We don't care where it saves the regression equation right now. Scroll down, it says it's going to paste the results into column C, and that's fine. We're going to go to OK and scroll up, because the data was pasted in way up at the top. And you'll notice we've got M, B, R squared, and R. Okay, so here's the R value that we have for this data. R equals negative 0.816. I'm going to go to 3 significant figures for my R values. And it says comment on this value. So what we would say about this is that this is a strong negative correlation. How do I know that it's strong? Because it falls within the breakdown 0.75 to 1. So hopefully on the previous slide you wrote down those breakdowns. I'll go back to it for a second. These breakdowns here, you want to record these in your notes so that you can make the accurate comment when you're doing your homework and eventually your project. You want to be able to say correctly if you have a very weak, moderate, or strong based on the number that you get for R. So this is a strong negative correlation, which makes sense. It's implying that, you know, the higher I guess I should say the lower your position, so the closer you are to being number 1, the more goals your team scored. So this is like as one goes down, the other goes up. And so you might have data like this for your project, or you might have variables that go up together. The correlation coefficient will tell you what that trend is. And that is all.